So how to succeed installing Tesla Powerwall 3 systems at Power. First, Tesla Powerwall 3 is a string inverter. This is completely different than SolarEdge and Enphase. All panels on the same string or on the same MPPT have to be on the same pitch and azimuth. You cannot mix and match panels facing different directions or in different pitches on the same string or on the same MPPT, or it will drastically reduce the production of that string. Next, we're going to need that string map and MCI map. When you're done, it's just like any other system. We need documentation of where every MCI landed, how you strung up all the solar panels. Without that, you're going to get a request for rework. MCI locations. I don't want to go into too far of detail here, but essentially we need one MCI every 3 solar panels, and it needs to be at least one at the beginning or end of every string. The ferrite cores. This is going to change depending on the model number of your Powerwall 3. Most of the models these days have 2 ferrite cores. One is going to go around your AC conductors coming into the Powerwall 3. The next is going to go down at the very bottom of the communications cable harness in the Powerwall 3. Again, check Tesla's documentation. Depending on the model number, that can change. The drain wire. So whether you're installing a backup switch or a Tesla gateway, you're going to have a shielded communications wire between the backup switch and the Powerwall 3 or between the gateway and the Powerwall 3. Now, you are not going to ground the end out there in the gateway or the backup switch, but you are going to take that little drain wire out of the end in the Powerwall 3. You're going to wrap it around that equipment grounding conductor and terminate it right there in that grounding block in the Powerwall 3. PCS. So Tesla comes out with a panel limit PCS of 80 amps by default on every project. If you do not change that, that means anytime the home uses more than 80 amps, the whole Tesla system is just going to shut down. We do not want that. So, power control systems, if we've got whole home backup in a Tesla gateway, where all home loads are downstream of the Tesla gateway, and that downstream breaker panel has a main breaker in it, then we just want to disable panel limit PCS altogether. Now, if we're in a situation where we have partial home backup, we have some home loads upstream of the gateway, or if we're installing a backup switch and we're just backing up all the electrical as it stands before we show up, we're going to need to enable panel limit PCS for the service. So you're going to want it to be 80% of the service rating. So for a 200 amp service, that's going to be 160 amps continuous panel level PCS. You know, for a 125 amp service, that's 100 amp continuous panel level PCS. For a 100 amp service, that would be 80 amps continuous panel level PCS. Import and export limit. So if you're in California under one of the 3 major utilities out there, that'd be PGE, SCE, or SDGE. We're going to need to program that for the net billing tariff or NEM3. That is going to be exports, both solar and battery. Grid charging disallowed, and that is going to be set to export only, and that is to comply with that NEM3 program. If you're in any other parts of the country, default to your specific utility. Most of them would export solar only. If you're involved in a VPP program, you're probably going to want to enable grid charging to your batteries. 2 forms of communication. So we need to get 2 forms of communication. Wi-Fi or Ethernet's generally your first form. Cellular is usually that backup form. So just make sure you get 2 out of those 3 options as a form of communication to the Tesla system. Remote meter. So that is going to be needed now anytime we have a partial home backup configuration, a downstream generator on site, or existing solar on site. This can get a little bit tricky for people that aren't experts in CTs, especially when it comes to polarity and phase alignment. We've got a more detailed course on that in Power University. Just reach out, I can sign you up. But essentially, We need to monitor all home loads. We need to monitor all existing solar. And if there happens to be a standby generator on site, we're going to need to monitor that as well. Once you're commissioning the system, you need to add Power PVC, Inc., DBA, Power Home Construction as a partner during the commissioning process so we can have monitoring access. You're also going to need to add the financier as a partner in that same section. Anytime you have a third-party owned system, that is going to be a lease or a power purchase agreement. There's a spot on PowerOS that says TPO, yes or no. If it says yes, we need to add the financier as a partner. Lastly, if you forget to add both power and the financier as partners on site, you can now do that online. You just go down to the little site. On the bottom left-hand side, there's a little share feature. You can share and then punch in the entities that you need to share monitoring access with. Lastly, the homeowner registration. What we need to send off that homeowner registration to the homeowner. They need to complete that registration or no one's going to have web monitoring access. And that needs to happen before you mark that installation complete on PowerOS. So just make sure you reach out to the homeowner, get them to complete that registration, verify that it is complete. If you have any trouble, reach out to your Power PM, have them reach out to the homeowner, but just wait to mark that install complete until you are sure this system's fully commissioned, all equipment's registered, everybody has access they need, the homeowner has registered the system, the PCS is set correctly, and we have all these photos in site capture. If you do all these steps, you're almost guaranteed to get 100% on your quality assurance evaluation and avoid those pesky reworks. Thanks so much for watching.